Hello everyone, welcome to add-on. So now we are going to solve this question based on FFD and BMD. As you can see here, we have been given a beam AE, let us say, and we have UDL at between DE, and it is an overhanging beam also between DE. We have a sudden movement at C and point force at P. We have been asked to calculate the SFD and BMD of the to draw the SFD and BMD of the following diagram. So let us see how we can solve this. Firstly, we need to draw the FBD of the diagram of the beam to find the support reactions at A and E, at A and D supports. Then we need to find the shear forces and then the bending moments at every point. To draw the SFD and BMD. So firstly, we'll draw the FBD of that beam. We have A, B, C, D, E. At A, we have a hinge support, so we'll have two reaction forces, which will be FAY and FAS. And there is an inclined force at the B. We'll need to resolve the force into two components, a horizontal and vertical component, for which this component will be 100 cos 50, and this will be 100 sin 50. Yeah. And at C, we have a certain moment of 100 Newton meter. And at D, there will be a vertical force of Fdy because it is a roller support. And because of the UDL also, there will be a force acting at a midpoint of the DE in the downward direction. So it will be 100 into 300, acting at 1.5 from D and 1.5 from E. The distance between CD is given as 2.5. 2.5 is also distance between BC, and AB is just 1. We have 9 as the total beam length, so 2.5 plus 2.5 is 5, this one 6, and 3 is 9. Yeah, it is total is coming out to be 9 also. We have drawn the FBD. So this is the FBD of the beam. Then we need to apply the equilibrium condition at in this beam, because the beam is in equilibrium, and in equilibrium we have three conditions, which is the summation of Fs is 0, summation of Fy is 0, and summation of movement at any point is 0. So what does it mean to apply the first condition is that you can add all of the forces in the horizontal direction and say that they cancel out each other, and that is why the beam is in equilibrium. So summation of Fx will be nothing but Fah is 100 cos 50, as you can see in the FBD. Summation of Fy, when you do it to 0, you have Fay minus 100 sin 50. Yeah. Because of the 100 sin 50 force at B, we have plus Fdy minus 300 because of the UDL is 0. So Fay plus Fdy comes out to be 300 plus 100 sin 50. So 300 plus 100 into sin 50 comes out to be 376.6. And third condition will be nothing but summation of movement at any point is 0. But in our condition, we'll apply it at A. Because as you can see in the equation, we have two variables, Fay and Fdy, and only one equation, that Fay plus Fdy is 376.6. That is called equation number 1. So we cannot solve this equation. We need another equation to solve this, which will come from the moment condition, and we will apply the moment condition at A, because then the Fay force will disappear and we only have Fdy in our equation. We have 100 sin 50 into 1, which is in the clockwise, so clockwise is positive, clockwise movement will be positive and anti-clockwise movement will be negative. And 100 sin 50 into 1 clockwise, so that is why it is positive. We have an anti-clockwise movement of 100 Newton meter at C. Sorry, it is a clockwise movement, so it will be 100 at, just add 100. And we have Fdy, which because of which there will be an anti-clockwise movement. So Fdy into the distance will be 6. And again we have a UDL force of 300 into the distance will be 6 plus 1.5, which is 7.5. Yeah. And it is in the clockwise direction, that is why it is positive, so it is equal to 0. We have 300 into 7.5. plus 100 plus 100 into sine 50 divided by 6. 404.4. So FDY comes out to be 404.4. This is equation number, let us say 2. So if you put equation number 2 in equation number 1, you will get the value of FA also. So 376.6 minus this will come out to be minus 27.83. So FAY comes out to be minus 27.8. Yeah. So this is your reaction values. As you can see, the reaction at A is nothing but minus 27, which means that the reaction is not in the upward direction, but it is in the downward direction. So you can just change your direction of the reaction. It is in the downward. So this is will be FAY in the downward direction. So I will just adjust this. Yeah. This is FAX. So yeah, you have been calculated. We have calculated FAY as a minus 27.8, FDY as a 404.4. Yeah. Next, we will calculate the shear forces at every point, which is necessary to make the SFD. So for that, we will follow a certain sign convention, which you need to understand, because that is an important sign convention. Either your answer will be different from the which is the correct answer. If you do not follow the sign convention, your answer can be of different value or of different sign. So you need to follow the sign convention accordingly. We have for shear force, we have whenever you are calculating from the forces on the left, we have upward as positive and downwards forces as negative. And whenever you are calculating from the forces on the right, we have upward forces as negative and downward forces as positive. So let us see what I mean by like the sign convention, how we can apply this sign convention into the problem. We have a shear force at A as a minus just right of A, you can say that it is and calculating from the forces on the left, so negative will be downward forces, and it is in the downward of 27.8 downward force. So that is why we will write that shear force just right of A is a minus 27.8, because we are considering force on the left. So this is somewhere, let us say this is your cross section right of A, and if you consider force on the left, then minus 27.8 will be your shear force. And let us calculate shear force left of B, just left of B. We have a minus 27.8 only, because there is no force right of A and left of B. Shear force just right of B. Again, we are considering force on the left only. So upward forces will be positive and downward forces will be negative. So let us say somewhere here you have crossed your B right of B. And there are two forces, as you can see, which is a minus 28. So this is FAY, which is minus 27.8, because it is in the downward direction. And also the 100 sine 50 in the downward direction. So it will come out to be minus 27.8. So 27.8 plus 100 into sine 50, 104.4 in the downward direction. So minus 104.4 will be your shear force right of B. We have shear force at C, same as shear force right of B, which is minus 104.4. Shear force just left of D, will be the same as what it was at C, which is minus 104.4, because there is no shear force in between C and D. We have shear force right of D. So right of D, when you are calculating, you need to add this FDY also, because right of D, let us say here, and you are considering force on the left. So we have left of D as a minus 104.4, and this add this FDY force, which is minus 104.4 plus 404.4, which is 300, and shear force left shear force at let us say at E, because there is no force at that point, so sudden force at that point, so shear force at E will become 0, because there is a UDL force also, so it is nothing but 300 force, which is right of D, which it was right of D, minus 300 because of the UDL, so it will become 0. So we have a shear force diagram like this. This is A, this is B, this is C, D, E. At D, we have a shear force of minus 27.8, so minus 27.8. At left of B, we have minus 27.8, right of B, we have minus 104.4, minus 104.4. And it is same at C, it is same at left of D, and the right of D it is 300, it is somewhere around 300, and E it is 0. And as you know that there is a UDL between DE, so this will vary like a linear line. And all the places other than that, it will vary like a constant line, which is like this. Yeah. So this is how you can draw your shear force diagram for the following problem. So let us see how we can draw the bending moment diagram now. Yeah, we have bending moment at A and E to be 0, because the extreme points bending moment will always go to 0 because of the equilibrium condition. Equilibrium. Yeah. Unless there is a fixed support. So if there is not a fixed support at E or E, then you can say that the bending moment at that point will go to 0. Or you can calculate also it will go to 0 at that point if you want to cross check this. Or you can just say that it is 0. Or next we calculate bending moment at V. Considering forces on the left, so the here sign convention for this will be, if you are considering forces on the left, then bending moment will become, for clockwise movement it will be positive and anti-clockwise it will be negative, and if you are considering force on the right, the clockwise will become negative and anti-clockwise will become positive now. So bending moment at B, considering force on the left, we have Fay in the downward direction, so it will make an anti-clockwise movement at B, or generate an anti-clockwise movement at B, which would be negative because it is an anti-clockwise movement. So 27.8 into 1 is minus 27.8. We have bending moment left of C, just left of C. So just left of C. So just left of C we are calculating because there is a sudden movement at C. So whenever there is a sudden movement, you need to calculate just left of C and just right of C to understand the variation of force at that particular point. We have 100 Newton meter sudden movement at that point. So that is why just left of C when we calculate. Let us calculate from the forces on the left. So just left of C there is a cross section and we are calculating from the left. So this movement we need not include. So we are calculating from the force on the left. So we have 27.8. There is an anti-clockwise movement because of this. So that is why minus 27.8 into the distance is 2.5 plus 1 is 3.5. And again there is an anti-clockwise movement because of the 100 sin 50 force into 2.5 is the distance between C and that force. It is an anti-clockwise movement, so that is why it is negative. 27.8 into 3.5 plus 100 into sin 50 into 2.5. It comes out to be 288.8 minus. So yeah, bending moment right of C. So right of C it should be minus 288.8, and considering forces on the left again, so there is an clockwise movement at C. So you need to add that movement, which is 100. So it will be minus 188.8. We have bending moment at D. So let us now consider forces on the right, because there are too many forces on the left. So just consider forces on the right will be easy for us. We have only one force on the right. So we have 300 into 1.5. 300 into 1.5. Which will be clockwise. So that is why we will give it a negative. Because for whenever you are considering forces on the right, the clockwise will become negative. clockwise movement will become negative. 300 into 1.5 is 450. Negative. We have bending moment at E is 0. So let us just make the bending moment diagram, because we have bending moment at every point now. This is A, B, C, D, and E. At A we have 0. At B we have minus 27.8. At left of C we have minus 228.8, minus 288, sorry, 0.8. And right of C we have minus 188, so minus 188.8. At D it goes to minus 450, so minus 450, and at E it goes to 0. And we know that the variation between D and E will be a parabola, because there is a UVL in between. So this is a parabola. And yeah. So between A to B there will be a straight line. Again there will be a straight line at C. There will be a sudden jump at C, and yeah, again a straight line between D to C. So checking, let us just check your values once. Bending moment at D we have yeah, considering on the right we have clockwise. Yeah, this is how you should draw your bending moment diagram. Thank you.